Recording is on.
Okay, so can everyone see the screen? Can the screen be seen by everyone? Can you see the screen?
Yes, sir.
Yes, sir.
Okay. So in the last class, we had been discussing about molarity. So molarity was the number of moles dissolved per liter of the solution. So we had come to the formula for molarity as number of moles of solute divided by the volume of solution in liter. That had been our formula for molarity. Number of moles of solute divided by volume of solution in liter. And then we had also seen some variations in the formula which we had derived. So one was the weight of the solute in grams divided by molecular weight of solute into the volume of solution in liter. And how did we come to this deviation? That is, we have done this by actually writing that number of moles was equal to weight by molecular weight. Number of moles was equal to the weight of the substance divided by molecular weight of the substance. This is how we had come to the number of moles thing. And then weight by volume of solution of the liter was written as strength. Weight by volume, that was written as the strength of solution, right? And finally, the last. Yes, did anyone say something? And finally, we have got the number of moles into 1000 divided by volume of solution in milliliter. So these are the four formulas that you need to remember regarding molarity. Okay, we have done these four formulas regarding the molarity of a particular solution. So if you see some numericals from molarity, that was we had been doing, and then the class had ended abruptly. So 3.92 gram of H2SO4 is dissolved in 200 ml of water. Calculate the molarity of solution. So these sums are easy if you can apply the formula correctly. So what is this? 3.92 gram of H2SO4. That means this one is the weight of sulfuric acid that is given to us. So weight of sulfuric acid is weight of H2SO4, that was 3.92 gram. 3.92 gram. Now you need to find out the molecular weight. In order to find out the number of moles, you must know the molecular weight. So molecular weight is equal to molecular weight of H2SO4. That will be 98. So let us show by calculation. 2 plus 32 plus 4 into 16. So that is equal to 98. If you do this calculation, you will see that it is coming at 98. So these certain values you must remember. By remember, I mean it is not essential for you to remember, but remembering these values will save you time in examination because these are very common formulas. So to not calculating their molecular weight is basically a waste of time in examination because these molecules are so common. That's why while practicing only you should remember their molecular weight so that you can save time in the examination. And then what is given to you? Volume of solution is also given. volume of solution is given to us. That is equal to 200 ml. So what is given? Weight of H2SO4 given, molecular weight given, volume of the solution is given as 200 ml. So which formula do you think is applicable out of these four? Tell me, out of these four, which formula are you going to apply? Which more formula should you apply from the data that are given? Here you are getting to see weight is given, molecular weight is given, volume is given in milliliter. So which formula will you apply from here?
So
Weight
second
is
formula.
the second formula, correct? So let us apply it. So the molarity is going to be molarity capital M, that is equal to weight of H2SO4 divided by the volume of the molecular weight of H2SO4 into volume of solution in ml, in milliliter, and at the top, because it is in milliliter, so in the numerator you multiply it by 1000, or you could have also written as volume of solution in liter. That is also perfectly acceptable. So just put down the values. It is given as 3.92 into 1000 divided by 98 into 200. So now let's do just the cancellation thing. This one will become 5 and this one must cancel by 98 only. See, it is ending with 32, so this one will be 98 4 32, 392. Yes, correct. So this one will be 0.04. 0.04. So what is the answer to this question? 5 into 4, that is 20. So that is 0.20 molarity. Okay, so this is how you calculate the molarity of a particular solution. Okay, is it clear to everyone? Is it clear?
Yes, sir.
So just see
Yes,
first in this sum, first observe in this type of numerical what data are given to you. Once you get to know the data, then see which formula is suitable. Now it is perfectly up to you how you utilize the formula, how you are going to utilize this formula. That is totally up to you. See, you could have also done this sum by this method also. See, you could have first another alternative way. This is the alternate pathway. And in alternate pathway also you are not doing any different. You are also doing the same thing even in this alternative pathway also. Suppose first in this alternate way, you first calculate the number of moles. Number of moles of H2SO4. So that is, what is the number of moles of H2SO4 over here? Number of moles formula is weight by molecular weight. Weight of H2SO4. Weight of H2SO4 divided by the molecular weight of H2SO4. Molecular weight of H2SO4. So this also we had written the formula. Number of moles is equal to weight by molecular weight. Weight by molecular
Sir,
weight. Yes, sir.
sir,
Hmm?
the meaning of strength.
What is the meaning of strength? Yes, strength is expressed by when you make the ratio of weight of the solute divided by the volume of solution in liter. This ratio is known as the strength of solution. So strength is basically concentration. Strength, that is another synonym, same meaning, different word. It's another synonym for concentration. So you can also write concentration of solution in gram per liter, because see, in the numerator you have gram and in the denominator you have liter. So that is why gram per liter. And strength is concentration only. The concentration of solution in gram per liter. Okay. Okay. So then you have weight of H2SO4 is given 3.92 divided by 98. So this you calculate and get your answer. We have already done that. This one will be 0.04. Okay. And then you find out the molarity thing by applying the first formula. Number of moles by volume of solution in liter. Number of moles of H2SO4 divided by volume of solution in liter. Okay, so that is equal to, what is the number of moles? 0.04 moles. So let us put it 0.04 mole divided by, what is the volume? 200 milliliter. So in liter it will become 0.200, or you can simply write 0.2 only. This is the volume in liter. So here also you are getting the answer as 0.20 moles. 0.20 moles. So it is totally up to you which method you will apply, because ultimately these two methods are exactly similar. In the second method, you are first separately calculating the number of moles and then applying the basic formula of molarity. And in the first method, you had used one formula only, and in that only you had simplified the basic formula. So the other formulas are not something different. The rest of the formulas are simply a simplification. It is simply a simplification of the first formula. Okay, I personally prefer using the first method, because in the first method you are doing the calculation at the last, so there is a lesser chance of error, whereas in the second method you have to do the calculation two separate times. Two times separately you have to do the calculation, so there will be chances of error in that, more chances of error. However, in this case, if you can put the values correctly, then here you get a comparatively lesser chances of calculation mistake, because here the number of calculation is only one time. In one time only you are doing the entire calculation. So yes, so the point is you can apply any formula you like, because all the formulas are just derived from one basic formula. Okay, now which one way you are comfortable with, go with that method. Okay, am I clear to everyone? And is the sum clear to everyone?
Yes, sir.
Okay, then what about the others? What about the others? Is it clear? Yes.
Sir, in second method, the answer will come 0.02, I think.
In the second method, the answer is coming at 0.02.
Yes.
Okay, if the answer is coming at 0.02, that means I have made a mistake somewhere. So then I have to find that mistake. 0.04 divided by 0.2. No, it is 0.2 only. It is coming at 0.2 only. Yes, it is correct, not incorrect. It is correct only.
Yes.
It is correct. It isn't incorrect. Like if you do it, if you want
Yes,
to do,
sir. For
okay, it is correct. Did you understand it? See,
yes,
this
sir.
will become 4 by 20. So ultimately 1 by 5. So that is 0.2. So it is correct, not incorrect. Because whichever, this is ultimately it's same method. It is not like that it is different. In the first method, you are doing the entire calculation together. Here you are doing it separately. Here also I am applying the formula of number of moles only. See, weight of H2SO4 by molecular weight of H2SO4. Just in the second method, you are calculating it separately at first. Whereas in the first one, you are doing it simultaneously in one equation itself. Now, let us see the next example. By next example, I mean the next example will be, suppose they might give you the weight. Weight might be given to you. And then you have to find out the molarity. So how to do that? Suppose they will tell you 0.92 grams of H2SO4 is dissolved in 200 grams of alcohol. Suppose it is said it is dissolved in 200 grams of alcohol. So now we have to find out the molarity. So let us take an arbitrary sum, just a random sum we are considering. That is 3.92 gram H2SO4 is dissolved in 200 grams of, suppose, alcohol, in 200 grams of alcohol. So you have to find the molarity of the solution. Molarity. You have to find the molarity of the solution. Okay. So 3.92 grams of H2SO4 is dissolved in 200 grams of alcohol. You have to find the molarity of the solution. Okay. So someone of you have your mic on. Okay. So it will be great if you turn it off and just switch it on during speaking. Okay. So see the mic, the symbol of mic is there like this. You have to switch it off. You have to mute it. So 3.92 gram is dissolved in 200 grams of alcohol. You have to find out the molarity. So how to approach this sum? Now see, here the problem lies that here they have not given you the volume of solution. If you see the formulas, one thing is very constant. That is, you need to know the volume of solution. That is a must. Without knowing the volume of solution, you cannot do the sum. Then what to do? Then you will see in this kind of sum, density will be given to you. Density must be given to you in this type of numerical. So density, suppose, is given as 0.9 is the density. Okay, so they have given you the density. So in this particular kind of sums, you might also be given the density. And with the help of density, you have to do the numerical. Okay, because density, if you know, what is the relation between density and volume? What is the relation between density and volume? What is the relation between density and volume? The relation is density is equal to mass by volume. Mass by volume. So you can get from here volume is equal to mass by density. Mass by density. And what is this mass? This is the mass of the alcohol, which you have to separately calculate, This one will be 24 plus 5 plus 17. So 24 plus 5 plus 17, and you will get your answer. Whatever comes, 24 plus 5 is 29, and 29 plus 17 is going to be 29 plus 17 will be 46. So this is the mass of the alcohol. So 46 divided by 0.9. So that will be giving you the volume. So that is going to give you the volume. And now that you have found out the value of this volume, now you can simply do it. So this will come at 51.1 milliliter. So you have got the volume. Now you apply the simple formula for molarity. Molarity is equal to weight of H2SO4, weight of H2SO4 divided by molecular weight of H2SO4 into volume of solution in milliliter and into 1000. So that is equal to weight of H2SO4 is 98 into 1000, 3.92, sorry, divided by 98 into volume is we have calculated 51.1. Now if you do this calculation, you will get your answer. Suppose this will come at X. Okay. So this is how you will approach the sum. So if you see in a particular numerical, the volume of the solution is not given. If in a numerical you get to see that they have not provided you the volume of solution, then your method of approach should be to first find out the volume. How do you calculate that? That is calculated by using the relation density is equal to mass by volume. Density is equal to mass by volume. This is a relation that will be used in this case. And thus volume is equal to mass by density. Density equal to mass by volume. So therefore volume will be equal to mass by density. Mass of the alcohol is already given to you, 46 divided by 0.29 grams, and then you calculate out the volume from here. Once you get the volume that is present, volume of the solution, then you can simply do the calculation and get your answer. Okay, so that depends on what set of data will be given. Depending on that, you have to select your method of action. Okay, then let us see the next topic. The next topic is the next formula. So we have done about molarity. Now it is time for us to learn about normality. Normality. So let us see what normality is. Normality. So can anyone tell me what normality is? Have you done this in school? Normality?
No, sir.
It hasn't been taught in school till now. So how far have they come at school? What are they teaching at school at this moment?
So first chapter is actually completed, but ma'am is not teaching that much nicely.
Acha, acha. So they haven't done this since?
Maybe done, but what ma'am is teaching we can't understand.
Acha, acha. So can you understand here at least?
Yes, sir.
Okay, then it is okay. So that shouldn't happen like you are not understanding in school also and not here also. Okay, if you do not understand anything, then immediately inform me. Achha. Then let us see about normality. So there is a slight difference between molarity and normality. Molarity was number of moles of solute dissolved per liter of the solution. And this one will be the number of gram equivalent the number of gram equivalent of solute dissolved per liter of the solution. per liter of the solution. So this is the definition. Number of gram equivalent of solute dissolved per liter of the solution. But more than the definition, we are interested in the formula of normality. So normality denoted by capital N, that is equal to number of gram equivalent, number of gram equivalent, number of gram equivalent of solute divided by volume of solution, volume of solution in liters. So our this one molarity was number of moles of solute, and this one is going to be number of gram equivalents of solute. So that is the basic difference between these two formulas. Okay, and
Even
how
that in
say
say that in previous question you done know that C5H5OH. In that 46 how came that volume 46?
46 is the mass. See, here we have calculated the molecular mass of alcohol. Molecular mass of the alcohol has been calculated as 46.
Okay.
Because it is carbon is 24, hydrogen is 5, mane hydrogen's atomic number is 1. So there are 5 hydrogens, so that is 5, and oxygen is 16 and hydrogen is 1. So you should do one thing, that is the atomic number. Do you know the atomic number of all the elements from 1 to 20? Do you know the
Yes,
atomic
sir.
number of all the elements from 1 to 20? Okay, so you know. Then what you should do is, now you should memorize from 1 to 30. That means 20 to 30 you should memorize it up, because we need it in our next chapters. So 21 will be scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So in class 11 also you have your chapter of periodic table, and there the periodic table is there also in whatever book you are following. Picture of periodic table is there in the chapter number 3. So from there memorize the elements from 21 to 30. Okay, so
Yes,
this
sir,
you must
understood.
memorize. And about the atomic mass, the mass number to you previously did not memorize, but here you should memorize the mass number of, if not all the elements from 1 to 30, but you should know at least some special element. That is, you should remember, because they will not be given in exam. So for hydrogen the mass number is 1, this you must know. Then for oxygen the mass number is, what is the mass number of oxygen?
16.
What?
16.
16, correct. So the mass number of oxygen is 16. Mass number of carbon?
12.
12. Mass number of nitrogen?
14.
14. And mass number of sulfur?
32.
32. Mass number of sulfur is 32. Okay. And mass number of chlorine?
35.
35.5. 35.5. 35.5. Okay. So at least these ones you should know. Okay. And from here sodium also. Sodium is 23. Sodium 23. Magnesium is 24. So these ones, so these 8 out of the first 20 you must remember, because they will not give you the value of mass number in the question paper, because it is now, since you have gone to higher classes, Now it is expected of you that you will remember this value. Okay. Now let us again come back to over here. So the basic formula for normality is number of gram equivalent divided by the volume of solution in liter. Okay. Now how do you calculate number of gram equivalent? So number of gram equivalent is calculated by weight of solute, weight of solute, weight of solute divided by the equivalent weight of solute into volume of solution in liters, volume of solution in liters. So this is how you calculate the value for number of gram equivalent. Just like you have calculated the number of moles as weight of solute by molecular weight of solute. That was our calculation to number of moles. Number of moles was weight of the substance by molecular weight of substance. So similarly, you get number of gram equivalent is given by weight of the solute by the equivalent weight of solute. So number of gram equivalent, that is equal to weight of substance taken, weight of the substance divided by the molecular weight of the substance, molecular weight of substance. Okay, so this is how you calculate the number of gram equivalent. Now you might wonder one thing, that is, what is this equivalent weight? What is this equivalent weight? We haven't done anything before about this equivalent weight. So wait a moment, let me complete all the 4 formulas and then we will discuss about what this equivalent weight is. So now let us do the next modification of the formula. So the next modification will be exactly similar to the molarity thing only. See, in molarity, we had written weight of solute in grams by the volume of solution in liter. This part had been written as the strength of the solution, weight of solute in grams divided by volume of solution in liter. That is basically the strength of solution in gram per liter. So here also we will write that only. That is strength of solution in gram per liter, divided by the equivalent weight of solute, So the formulas are very similar. Just over there, we had been dealing with molecular weight. Here you are dealing with equivalent weight. Other than that, the formula for molarity and normality, they are very similar. And the last formula was number of moles of solute into 1000 by volume of solution in milliliter. So here also the last one will be the exact same time. That is the number of gram equivalent of solute, divided by volume of solution in milliliter, and in the numerator you multiply it by 1000. Okay, so the only difference between molarity and normality is going to be molarity is dealing with the molecular weight. In every part of the formula, if you just replace it by molecular weight, you are getting the molarity thing. Whereas the normality is dealing with the equivalent weight of a substance. That is the only difference. Acha, can you tell me one thing? Will molarity and normality depend on temperature? Is molarity and normality dependent or independent of temperature?
That depends.
So both of molarity and normality is dependent on temperature. Why? What is the reason behind it? What is the reason behind your answer? What is
Because
the
we are using liters.
Yes, because here both the definition has volume. So in
Yes.
both the definition, volume is involved. And we have already learned in lower classes that volume increases with increase in temperature. So as a result of that, both molarity and normality is dependent on temperature. Okay. Then, so these are the formulas pretty much similar to the molarity thing. Now let us understand what the equivalent weight is. What an equivalent weight is going to be. Equivalent weight of a solid or equivalent weight or equivalent mass, whatever you say. Equivalent weight Now this concept of equivalent weight, this I doubt is there in your NCERT books, okay? Because in NCERT books, they have just touched this normality thing. So equivalent weight might not be there in their NCERT book. So just read from here, nothing that much difficult. So what is this equivalent weight thing? So equivalent weight is basically, see, whenever we are doing a reaction, whenever a reaction is being done, it is obviously not that everything is reacting together. Suppose if you take 100 grams of a substance, if you take 100 grams of the substance, it is obviously not the case that always 100 gram is only reacting instantly. It is not happening like that. Maybe it is reacting in installment. That means in the first time 50 grams react, in the second time the rest of the 50 grams is reacting. So that is how the reactions are occurring, because the reactions occur in steps. Reactions are occurring in steps, stepwise happen. It happens in a step. So that is why the total mass of the reactant does not occur in a single step. That is not happening. Rather, it is happening in installment. And that is only the equivalent weight. So equivalent weight is how much amount of the substance, is reacting in a singular step. How much amount of the substance is reacting in a single step. That is the equivalent weight. Mane, this is the definition for equivalent weight, just for this understanding purpose. And if you have to like write down the definition in examination purpose, then again the mic is on. Okay? Again that mic is on because you are having some background noises, so that will be a source of disturbance for others as well. So yes, now it is off. So regarding the equivalent weight, what did I tell? That equivalent weight is going to be how much of the substance is reacting in a single step. In the single step, how much of it is reacting. That is only the equivalent weight. This is the normal understanding definition about equivalent weight. However, if you have to write the definition of equivalent weight in examination purpose, then you have to write a standard definition, and that is a huge definition, which will cover an entire page. So I am not writing that definition because we don't need the exact theoretical definition for examination purpose. So you just remember that equivalent weight is how much amount of the substance is reacting at a singular step. And we are more interested in finding out the equivalent weight of substances, how to find it out. So you see, there can be multiple methods by which you can find out the equivalent weight of a substance. That is, the first of all, it will be equivalent weight of an element. equivalent weight of an element that is given by atomic weight divided by valency. So that is the equivalent weight of an element. Okay, and again about this chapter that we are learning now, that is this section, molarity, normality, and the rest that we'll be doing. You have this in class 12 also. Okay, in the first chapter of second. In the second chapter of class 12, you have these things once again. So in your final class 12 board examination also, you will get one question from this segment. So that is why I do this section nicely. And that is the reason why you are doing normality now only. Because now we are reading this chapter. So it is easier for us to grasp that concept. Normality might not be there in details in your class 11, but it is there in class 12. So let's do it now. So it is given by equivalent weight is equal to atomic weight by the valency. So equivalent weight of an element is atomic weight by valency. So for example, suppose if I give you Cu2O, then can you tell me what is the equivalent weight of copper? Equivalent weight of copper. So that is atomic weight. Atomic weight of copper, I am telling you, this will be 63.5. This you do not need to memorize because hopefully this will be given in your examination paper. So the atomic weight of copper I have written. Now can you tell me what is the valency of copper in this formula? What is the valency of copper in this formula?
2.
No, copper is not 2 in this case. The valency of copper is not 2. The valency of copper over here. How to find out valency from a formula? By those diagonal multiplication thing. That is, if we write this formula more simpler, in a more simple way, then this one will become Cu2O1. I am writing O1 because nothing is there means 1 is there. Then what do? Then you do those diagonal cross thing. So copper is getting 1. So you are getting Cu plus 1 and O2 minus. Okay. Is this valency calculation clear to everyone? We have done this in lower classes of 9, 8 and 9 where you have to diagonally do it. So write the formula and diagonally cross multiply this. So 1 is going on the head of copper. So that is why in this case, the valency of copper is 1. So you are getting that this to be as 63.5 only. 63.5. Okay. However, if suppose I had given you this formula, that is CuO, copper oxide, CuO, that is the, and then if I ask you about the equivalent weight of copper, now what will be the answer? 63.5 divided by how much? What is the valency of copper in this case?
2.
2. So copper can be basically either 1 or 2. Okay. When we learn about in the next chapter of atomic structure, then you will get to see that the valency of copper can be either plus 1 or plus 2. And how do you do this calculation? This is done in this way. See, copper is 2 and oxygen is also 2. Because oxygen has to be 2. That is why we have written it. Copper should also be 2. Then you do the interchange thing. So you are getting Cu2 plus and O2 minus. Bas. So 63.5 divided by 2. So that is coming at, this one will be 31.75. So you are getting the equivalent weight in this way. So can you one thing you can conclude from here, that for the same element, for a same element, equivalent weight is inversely proportional to the valency. Because see, as the valency has increased, the value of equivalent weight has also decreased. As the valency of copper has increased, the value of equivalent weight has also decreased. So the equivalent weight is inversely proportional to valency. Okay, then. So this was the equivalent weight of a element. Now, what if I want to calculate the equivalent weight of acid? Equivalent weight of acid. Equivalent weight of an acid. See, for acid the formula is equivalent weight is equal to molecular weight divided by basicity of the acid. Basicity of acid. That is the formula for equivalent weight of an acid. So now tell me, have you done about the basicity of acid in class 10? Do you know what the basicity of an acid is? Have you done it in class 10 in the chapter of acid and base?
pH level.
No, not the pH level. This is different than pH. Basicity of an acid. Have you done such thing like monobasic, dibasic, all these things have you done?
No.
Okay. So then let us see this. So basicity is basically, basicity of an acid is the number of replaceable hydrogen atom. Per molecule of the acid. Okay. So this is the definition. Basicity of an acid is the number of replaceable hydrogen atom per molecule of the acid. So again, we are not interested in the definition. We are interested in understanding, applying the definition. See, HCl. So how many hydrogen are present in HCl? How many hydrogens are present in HCl? Only one. So it will dissociate to produce H plus and Cl minus. You have done this type of things, reaction in class 9-10. So HCl is dissociating to give H plus and Cl minus. So tell me, so from one molecule of HCl, how many H plus did you obtain? How many H plus did you get from one molecule of HCl? Only one. Only one H plus has been obtained. So that is why we say for HCl the basicity is 1. Because from one HCl molecule you are getting one H plus. That's it. So it is a basicity is 1, and such acid is known as monobasic acid. Now see, if you are taking H2SO4, if you dissociate H2SO4, what do you get? There are two hydrogen, two replaceable hydrogen, 2H plus SO4, 2 minus. So from one molecule of sulfuric acid, how many H plus ions are you getting? 2 ions you are getting. So that is why the basicity is equal to 2. So that is why this is a dibasic acid. So are you understanding what basicity is? Basicity is basically how many replaceable hydrogen. By replaceable hydrogen means how many H plus ion the acid can produce. Okay. Am I clear to everyone regarding basicity? So then you tell me for H3PO4. H3PO4. So what will be the basicity of H3PO4? What will be the basicity of H3PO4?
3.
3. Because H3PO4 is dissociating to produce 3H plus PO4 3 minus. So basicity is basically 3. So that means this is a tribasic acid. Tribasic acid. Okay. Then can you tell me what will be a basicity of acetic acid CH3COOH? What will be the basicity of acetic acid?
4.
Yes?
4.
No, this one is not 4. So the basicity of
2.
acetic acid is 1. Acetic acid is a monobasic acid. Because if you look into the definition, I did not write number of hydrogen. The definition was not number of hydrogen. It is number of replaceable hydrogen. So when you learn about organic chemistry, then you will see that all the hydrogen from this molecule cannot be replaced. Only this hydrogen can be removed. The other molecules, the other hydrogen, since they are bonded with carbon, so that is why it is not possible to remove those other hydrogen. So only one hydrogen can be replaced. And the rest, other 3 hydrogens, they remain in the anionic form only. So that is why for acetic acid, the basicity is going to be 1. So this is how you get the basicity. So now tell me what will be the equivalent weight of H2SO4, equivalent weight of H2SO4, that is equal to molecular weight of H2SO4 divided by the basicity of H2SO4. So molecular weight we have calculated today only in that numerical that we did. So molecular weight of H2SO4 is 98. Okay. Divided by what is the basicity of H2SO4? That is 2. So 98 by 2, that is 49. So this is how we calculate the basicity. Sorry, this is how we calculate the equivalent weight. Okay. So is it clear to everyone? Calculation of the equivalent weight of an acid. So the formula is molecular weight by basicity. Molecular weight by basicity. And how to calculate basicity, that also we have learned. Now is simple division. Okay. So is it clear? Equivalent weight of an acid.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So then we have the equivalent weight of a base. Equivalent weight of a base. So how to do this? This will be slightly different from the previous one. So equivalent weight. How many students are there in the class at this moment? What is the total number? Just check and tell me.
9,
9. 9 including me or excluding me?
excluding you.
Excluding me. Okay. Then equivalent weight, that is we have molecular weight. Molecular weight divided by the acidity of base. Acidity of base. So now what is the acidity of a base? Acidity of a base, acidity of a base is the number of replaceable OH minus ion, OH minus ion per molecule of base. So just like the previous one was number of replaceable hydrogen, and here you have the number of replaceable OH minus, as simple as that. So now you tell me what will be the acidity for sodium hydroxide. What is the acidity of sodium hydroxide? Sodium hydroxide has only one OH minus, Na plus OH minus. So that is why the acidity is 1. So that means this is a monoacidic base. Then suppose if I give you magnesium hydroxide, what will be the acidity? Tell me. No exception, just simple thing. What is the acidity of magnesium hydroxide? How many OH are there in magnesium hydroxide? Just by looking at the formula, say 2. So that means this one will dissociate into magnesium 2 plus 2 OH minus. So that means acidity is equal to 2. So this one is a diacidic base. Okay. And then suppose if you are given aluminium hydroxide, then it is Al3 plus 3 OH minus. That means the acidity over here is 3. So depending on the number of replaceable OH minus ion, you can find out the acidity and basicity of the solution, and thus you can naturally find out the equivalent weight of the acid and base from here. Okay, so this is how you find out the equivalent weight of the acid and base. Then the next one, rather the last one regarding equivalent weight calculation, that is how to calculate the equivalent weight of salts. Equivalent weight of salts. So all the 4 has different formulas. So equivalent weight of salt is given by that is molecular weight divided by number of cation into valency of cation. Number of cation into the valency of cations. Okay. So suppose if I give you Na2SO4, So you have to find the equivalent weight of Na2SO4. So quickly calculate the molecular weight and tell me what is the molecular weight of Na2SO4. Molecular weight is sodium is 23. So 2 into 23 plus sulfur is 32 plus oxygen is 16. 4 into 16. So that is 46 plus 32 plus 64. So if you add it up, this should come at 100, 110, 142. 142. 142 is the molecular weight. Now tell me, if you break this, how many cations are you getting? 2 sodium atoms, 2 Na plus, 2 Na plus, and 1 sulfur, SO4 2 minus. So there are 2 sodium, as you can see, Na2. So there are 2 sodium ions. So the equivalent weight is becoming equivalent weight is equal to 142 divided by number of cations. So how many sodium cations are there? 2 into valency of cation. What is the valency of sodium? 1. So 2 into plus 1. So that is equal to 71. So this is how you calculate the equivalent weight of salt. So sometimes you can directly get numerical where you have to simply calculate the equivalent weight only and nothing else. And you do not have to do normality or anything as such, just you have to do the equivalent weight calculation. So that type of numerical can also come. Okay, so this is all about our equivalent weight. So is it clear to everyone? So what I would suggest you is to read through this part of equivalent weight, and in the next class we will start with some more example of calculating equivalent weights. I'll be giving you some other examples of molecules. You have to calculate the equivalent weight and tell me. So for that you revise this section. Okay. So is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So how are you finding the chapter till now? How are you finding this particular chapter till now? Is it easy, interesting, difficult, boring? How are you finding this chapter?
Easy, sir.
Easy. So then it's very nice. So, but one thing that I am again telling you, like every day only, that is this chapter is highly dependent on the numericals. Okay, it's very, very dependent on the numericals. So please practice the numericals as you are going on with the chapter. Okay? See this first only, do not think of solving the numericals. There is a high probability that you will get stuck. So first see the solved examples that is there in the book, or see the questions that you are discussing. First see them, see the solution. Practice by just copying the solution only. Then first, once you practice the numerical by just simply copying it down, understanding each and every step, then your next work will be to hide that solution, to just put a cover on that solution, and next day try to do the same numerical by yourself. And by yourself, I do not mean like memorizing the numerical and doing it, not that. Do try to solve the numerical logically by understanding without seeing. So first time you just see and copy down the numericals, understanding each and every step. Then after one day, again you sit with the same set of numericals, and this time practice by covering the solution. Do not see. Then once you get confidence in the solved examples, then you move on to the unsolved examples and try solving the unsolved examples. Okay, because numericals are very, very important. And if I am to tell you like very truly, this chapter is not a easy chapter, and questions can be made which can become like very difficult depending on the level of the question paper. Although it is very unlikely that they'll be giving you such tough question in your school exam. But yes, if you are targeting any other exams like competitive or anything as such, then questions can be made quite tough from this chapter. And in fact, like those who are giving those NEET or JEE, all those competitive exam, if you like make a survey, then there will be at least 60% student of those who are appearing for those competitive exam. 60% students are not confident about this particular chapter. They have a certain kind of stigma attached to this chapter, thinking like it is difficult, I will not be able to solve this question or anything like that. So that is why the only way to avoid that is practicing enough. So those who have practiced, what I've said is, those who have practiced enough numericals from this sum, they have become confident. And the thing is, if you are confident, once you get that confidence regarding this chapter, then is whatever numerical comes, you can easily solve it. But you, until and unless you do not get that confidence in you that you will be able to solve any sum, till that time this chapter will give you trouble. So that is why practice more and more sums from here. Okay. So then that's it for today. So bye everyone. I'm disconnecting the call.